Hi, welcome to another fun video on linear algebra. So today we're going to be going over matrix operations. Now, these are very important because they're crucial to the entire class. So let's get into it. So the first one we're going to be dealing with is matrix addition or subtraction. Okay, so this one is not that bad. If you know anything about vector addition, you basically multiply the x components with the x components of the other vector, and you multiply the y components with the y components of the other. So this is the same concept. You're going to be adding or subtracting. I should add that. The a components. Let's say you'll be adding the b components with the b components, and the c with the c prime, d with the d. So the new matrix will be there will be a plus or minus a prime, since we're only adding those a components basically, right? The b plus or minus b prime, b plus or minus b prime. So the addition and subtraction is not that bad. And the c plus or minus the c prime, you're only adding those. D. Okay, I hope you get the point. Be careful with signs. I know a lot of students, including I did, if there was a matrix that was like minus a plus, I don't know, something like that, I would totally disregard those signs and I would mess up. Don't be like me. Don't mess up. But yeah, be very, very pay close attention to those simple things, because we're doing simple addition in this case, so it's definitely disappointing when you try to do simple addition and you mess up. So that was matrix addition or subtraction. Let's talk about multiplication. So let's say that you want to multiply this k value, right? K is a real number. If you multiply k to this whole matrix, you have to multiply it to every single term. So as you see here, k is multiplied to every single term. K times a, k times b, k times c, k times d. So that shouldn't be too bad. Let's see what's next. Do you guys want to see a problem really quick? Let's just make up a problem. Let's say we want to multiply 3 to this matrix, which is 1, 2, 4, 2. Our resulting matrix would be 3, 6, 12, 6. Because you do have to multiply that 3 to every single term of that matrix, right? No problem. Ooh, matrix multiplication. Now this one is the trickiest, so pay close attention. Okay, so we have this matrix A, B, C, D, and we want to multiply to A prime, B prime, C prime, D prime. So this one is not too too easy. So let's get into it. So in order to multiply matrices together, you take this first term. Let's pull out a highlighter. Okay, so you take this row, AB, and you multiply it with this column. Okay? So what we just did is what we have to do is multiply A and A prime, and we add it to B times C prime. Okay, I hope that was pretty clear. So that was A times A prime plus B times C prime. And that is the first term in our matrix. So whatever that is, that's our first term. So now we're going to do that same row, A and B, and we're going to multiply it to B prime, D prime. Okay. And that is going to be A times B prime plus B times D prime. Okay. And I'm trying to organize this as clean as possible. Okay, so now that we're done with this first row, this A and B, we've multiplied it to the second matrix, the first and second column. So now we're going to go down to C's and D's for the first one, okay? So we're going to take C and D, and we're going to multiply it to that A prime and C prime. Okay, so what does that get us? So we're going to do C times A prime plus D times C prime. So it's the C times A prime plus D times C prime. So that's how we're multiplying it. Let's do the last one. Last but not least, we're going to do the C and D, and we're going to multiply it to this. So then we get C times B prime plus D times D prime. Okay, and that is how you multiply matrices. That's the only way that you multiply matrices together, is this extremely convoluted way. So I hope you get that. If you don't, you can go ahead and replay this part because this is important. Let's go ahead and move on. So after you've done that completely convoluted way of multiplication, this trace of matrices, the trace is a lot easier because, let's look. With trace, all you're going to do is add these A and D terms. You're going to add, let's go ahead and write that down. You're simply going to add diagonally. So you're adding diagonally. So you have this term A plus D. A plus D. The trace of A, this is the matrix A. So the trace of matrix A equals A plus D. So really quick, let's say if our matrix A was 1, 2, 3, 4, and they wanted us to find the trace of matrix A, that would just be the summation of the diagonal terms. That's 1 plus 4 equals 5. So the trace of matrix A is 5. That is not bad at all. Oh, transpose. I'm acting like this is a surprise. Like, oh, transpose of matrix. No, I wrote all this down, so it's not a surprise at all. So let's go ahead and look at this. Let's say we have a matrix A. So this matrix A is equal to A, D, C, D. And if we find the transpose of A, which you'll see as A to the power of T, this is the transpose of the matrix A. All you're doing is you're making the columns rows. So over here we have this column AC, but now the new row is AC. So these columns become rows. Okay, so this column BD will now become a row, BD. So, yep, that's basically the transpose. So let's do the transpose of B. This matrix B is we're going to make this column 3, -1, 1, and we're going to make it a row. We're basically flipping, we're turning it. Okay, so if we look over here, oh, now 3, -1 is a row. And this column 0, 2, 1 is now a row. 0, 2, 1. That's basically it, all it is. So you can also have DA, which is basically just multiplication. So if you have these columns 0, 2, 0, -2, 11 will become rows. Columns again become rows. Okay, no problem. So if we were asked to find 4 times the transpose of 7b, okay, and the B is this matrix. So let's go ahead and compute 7b first. Oh, okay, this kind of looks like when we had the K times a matrix. So when we have 7 times B, all we're going to do is, well, maybe let's write it out in steps. So we have 7, and our B is 4, -1, 0, 2. So that is going to equal, we have to multiply that 7 into every single term of the matrix. So 28, -7, 0, 14. Right, so 7 times 4, 28, 7 times -1, -7, 7 times 0, 0, 7 times 2 is 14. So this is equal to 7b. Okay, let's find the trace. The trace of 7b is equal to 28 plus 14. That's going to be equal to 42. Okay, trace of 7b is 42. And it's asking us to multiply 4 to the trace of 7b, which is just 4 times 20. I'm sorry. 4 times 42, which is 168. So the 4 times the trace of 7b is equal to 168. Ding! Okay, let's do another. Okay, so B minus the transpose of B. So this is our matrix B. So let's go ahead and find the transpose of that. So we have 4, -1, 0, 2, minus the transpose. What's the transpose? So these columns will now become rows, and these columns will become rows. So if we make that switch, we have 4, 0, -1, 2. Okay, and this is another matrix operation. So 4 minus 4 in our new matrix, we're going to get 0. -1 minus 0. See, this is why we have to pay attention to the signs, because I don't know, sometimes that might become a positive one. Let's see, 0. Oh, another reason why we have to pay attention. 0 minus a -1 is 1. And we have 0 for 2 minus 2. So this is equal to B minus B transpose. Okay, no problem. What else do we have? Find A times B times C. Oh, so this is where we have to do matrix multiplication. Fun. So we're going to take matrix B and matrix C. So we have 4, -1, 0, 2. And we're going to multiply that by C, matrix C, which is 1, 4, 2, 3, 1, 5. Okay. Let's just do the multiplication. Let me say this first. Let's see. Matrix B is a 2 by 2 matrix, and matrix C is a 2 by 3 matrix. Okay. So what does that mean? 2 by 3. No, that doesn't mean like a hamburger at In-N-Out. Not sponsored or anything. But what it means is there's 2 rows and 3 columns. So when you multiply, when you do matrix multiplication, if these here are the same, so you have 2 and 2. If that's the same, your resulting matrix after you multiply it, it should be a 2 by 3 matrix. And that's how you check to see if like your multiplication of matrix worked out. Is that if you have a 2 by 3 matrix. So that means if you have a 2 rows and 3 columns. If you have that, you did it correctly. So that's one way to kind of reassure yourself that you did it correctly. So let's go ahead and multiply this. So what we're going to do is we're going to take this first row, 4, -1, and we're going to multiply by this first column. Okay, so 4, I think I should write it out. I don't want to get confused either. So we have 4 times 1 plus -1 times 3. So that's 4 minus 3, which is 1. So our first term in B times C will be 1. If let's see, if I do -4, 4 -1, multiply that by that other column, I have 4 times 4 plus -1 times 1. I have 16 minus 1, which is 15. Okay, then I do the same. I have 4 times 2 plus -1 times 5. I have 8 minus 5, which is 3. So that's 3. And if I do the same with the other, with this column, this row, and I multiply with each column, I will just give it to you. It's going to be 6 to 10. So that is the product of the matrix B times matrix C. Okay, now that I have my B times C matrix, again this is B, C, and this is my A. Now it's asking me to multiply the A matrix times the B times C. I have to do the exact same thing with these two matrices. So this first row, I'm going to multiply to this first column. And then that first row again, multiply that column. And then that first row to that column. And once I'm done with that, I'll have to do this row with this first column. And then that row with this second column. That same row with the third column. Then I'll do this last row of A, and I'll multiply it to those columns. And after I'm done doing that, my answer will be 3, 45, 9, 11, negative 11, 17, 7, 17, 13. So this is the answer, A times B times C. And if I look, that is my answer. So make sure to practice these operations because they are pretty crucial to the entire class. So thanks for watching. Next time we're going to be looking at the inverses and properties of matrices. So thanks for watching and join me on my next video.